So today we're going to look at 7.2, which is transformation of exponential functions. Basically, we're going to take the exponential function that we looked at yesterday and add in our a, b's, h's, and k's, or our a, b, c, d's, or basically our a is our amplitude. It's going to stretch it. Our b is going to compress it. Our h is going to shift it horizontally, and our k is going to shift it vertically, right? You just basically take the whole graph and you shift it, remembering that your c has to be greater than 0, and when your c value is between 0 and 1, you have a decreasing exponential function. And when your c is greater than 1, you have an increasing exponential function. Okay? So if we have an a value, so this is our regular equation. Now if we look at this blue line, if we let it be y is equal to c to the x, we could figure out what our constant was just by looking at what it is at 1, right? At 1 it's 2, right? So we can say y is equal to 2 to the x. That's that blue graph. Now, if we look at the red graph, what is happening is every single point is doubled, so, or doubled, tripled, right? So we take our a value, or our original y value is 1. If we multiply by 3, gives us 3. And if we take our y value at 2 here, if we multiply by 3, it gives us 6. Our y value here at 4, if we actually went up, it would be at 4 times 3, 12. Now if we look here, this is at 1/2. 1/2 times 3 is 3/2, which is right there. So basically, we took this original formula of y is equal to 2 to the exponent of x, and we have y is equal to 3 bracket 2 to the x. Okay? So we've changed all the y values. So just remember, when you have an a, you're taking every single y value point and multiplying by that a. Now, if we look at this green graph, and take a look at what's going on, this was at a positive 3, this is at a negative 3. This is a positive 3.5, this is a negative 3.5. What it actually is, it's taking the y value and you're multiplying it by a negative 3. So that green graph is y is equal to negative 3 to the x. So if you have a negative a value, it basically flips it around the x-axis, right? So if you have a negative a value, you're going to invert the graph. So that's your a's. Let's talk about b's. Now our b value, so we're still going to look at this blue graph. If we take a look here on our blue graph, it's at 1, and then at 1 it's at 2, right? So the same thing, we're looking at a regular y is equal 2 to the x. Okay? But now something is changing, and we're not changing the a, because you'll notice that at 1, at 0 and 1 is at 0 and 1, and it stays there. But it gets smushed, right? So because it's getting smushed, we're probably thinking we've got something happening with our b. Now, back to our original graphs, we had 1 over the absolute value of b. So basically, we're smushing it by something. Now, we've got to figure out what are we smushing it by. So if we take a look, we're moving it over, right? So we're smushing it by some sort of factor we're dividing by. Okay? So we're smushing it in. So our x values are changing. What are they changing by? Well, if I look here, this is 1. Now, it looks like it's a third of the way in, right? So we're squishing it maybe by a third. How can I double check here? This is 2. If I squish by a third, that will be 2/3. That's good. Where can I really check? Well, if I'm squishing it by a third, if I look at where is it 3, it should be at 1, right? And at 3, it is at 1. Sorry, let's really look at where is it 3. It's at 3 right here, right? So at 3, is it at 1? Yep. Okay, so our B value would be 3. Now, going back to that general equation, if we look at it, our B value is now up there as part of the exponent. So if I was going to write this graph, this red graph, it would be y is equal to 2 to the exponent of 3x, because we squished it by a third, right? 3 to 1. Now, if we look at the green graph, it's just showing you, okay, we squished it by a third, but then we also flipped it on the y, around the y-axis. So that is changing your B value to a negative. So just be careful. If it switches from an increasing to a decreasing graph, you might just be flipping your B value. You actually are flipping your B value as becoming a positive to a negative or a negative to a positive. Okay? Now, if it looks like the exact same curve, okay, so we see here nicely, we have this blue curve again, and we look at 1, it's at 2. So our original graph, when it's hitting 1 here, and then the next one's hitting at 2, our original graph is y is equal to 2 to the x. It looks like it's the exact same curve, it's just shifted. Okay? Now remember, because in the general formula, our general formula says y is equal to ac to the exponent of b bracket x minus h. Sorry, let's go back and just double check. Plus k. Oh, plus k, and that's not an exponent part. That is a minus h, so when we pull it out of the brackets, it'll become a plus h. So this green graph, we're shifting it over 1, 2, 3 spots, right? 1, 2, 3, every single point. 1, 2, 3. Will be over 3. So when we want a plus 3, when we put it into the brackets, it will be a minus 3. And if you want to shift it the other way, when we pull it out of the brackets, we want it to say minus 3. So we put it as y is equal to the bracket x plus 3. So when we pull it out, it'll say minus 3, and we'll shift it that way. Okay? So it's just like the A's, B's, and C's, but now they don't like to write the C's because of the fact that that is our constant. So we write it as H's and K's, just like we did with parabolas and stuff like that. Now, your vertical translation, so you'll take a look. This is the exact same curve again, right? This is our original curve. At 1, it's 1, or at 0, it's a 1. At 1, it's 2. So our original graph is y is equal 2 to the x. It's the exact same curve. It's just shifted vertically up. So up, 1, 2, 3. Up, 1, 2, 3. Up, 1, 2, 3. It goes up 3 each time. So if we're going to draw this red line, y is equal to 2 to the x plus k. And because it's not in the brackets, we put plus 3. Same thing goes for that green one, but we're going down 3. So we write y is equal to 2 to the exponent of x minus 3. Okay. Now, when applying transformations, you must apply parameters for a and b before h and k. So you do a and b just like we did before with all our other ones first, and then you do the shifting. Okay, so we do the stretching and compressing, and then we do the shifting. Okay, so what would I do in a graph in this case? Well, we can do a couple different things. We can just write down what we're doing to each point and then deal with it. So for example here, I don't see an A, so I see an A of 1. I see a B value of 2. and I see an h value of -1, and my k value is 0. So what does that do in the brackets? Well, my x value is multiplied by 1, so it's 1x, subtract 1 because that's that shift, comma, my y value, we got to deal with the b. How did we deal with the b's? Going back. Our b values was 1 over b times x, right? So this will be 1/2. Sorry, my b values, I got to go back here. My b values deal with x. My a values deal with my y values. Sorry, I got it backwards. So we got to come back here. My a values deal with y, so this should say 1y. And my b values deal with x, so this should say 1/2 x. Okay? And there's no k, my k is 0, so it's plus 0. So my point should say 1/2 x, comma, or subtract 1, comma, y. Now, this was really good that we could actually come up with values then. And realistically, we could do a table of values using it. Sorry. And just pick different x values and different y values. If I put 1 in for x, what do I get for y? Stuff like that. But lots of times, I just like to originally draw the graph and then do all the stretches and stuff to it. So if I make this my x-axis and this my y-axis, if I did an original graph, so if I graphed y is equal to 3 to the x, I get 1 and 0, 0 and 1, I get 1 and 3.